Today we will learn about the add instruction in assembly. If you wanted to add two numbers, n1 and n2, you'll use the add instruction in assembly language. This is the syntax for add instruction. In this instruction, RD is your destination register, Rn is your first number n1, and operand 2 is your second number n2. Rd and Rn should always be registers. Operand 2 can be either a register or an immediate value. Let's see how it works. The table shows the registers x0, x1 and x2 and the values they currently hold. x0 doesn't have anything in it right now, but it can also be a random value or a garbage value. x1 and x2 hold the numbers 10 and 5. For our convenience, I also have the syntax for the add instruction from our previous slide. When you execute this add instruction, the numbers in the x1 and x2 registers are transferred to the arithmetic and logic unit on the processor, and the processor adds them together. Now the processor has the result 15, but it needs to store it somewhere. I chose x0 register as the destination register. So it takes my result 15 that's in the arithmetic logic unit or ALU, and it is going to transfer it back to the register x0. Using this instruction, I am adding two numbers 10 and 5 that are stored in the registers x1 and x2. Now we are calling this second parameter or the third parameter in the add instruction an operand. The reason is, I told you before, it can be either a register or an immediate value. Let's consider another example. This time, instead of using the register x2, I'll be using an immediate value number 5. As you can see, I don't have anything in x2. In this case, the processor takes the n1 stored in x1 and the immediate value 5 and adds them together. The result 15 is stored back in x0. That's how the two different types of add instruction works. Now let us see these two examples in action. I will go over echo and why we use it in another video. Echo will only work on Raspberry Pis and QEMU on WSL. I have my template here. I already have my global start and the termination code here. First I'm going to store 10 in x1 and 5 in x2. So move x1 comma 10 will store the integer value number 10 in register x1, and move x2 comma 5 will store the integer value 5 in x2. Now I'm going to use my add instruction. I will add the values present in x1 and x2 and store the result back in x0. Please remember, x0 is my destination register, x1 and x2 hold my numbers n1 and n2. Let me see how it works. I'm going to use the build file. There we have the result 15. If I change this number to, let's say, 10 and build it again, it's going to give me 20. That's how we use both registers in the add instruction. What if I have a register and an immediate value like we discussed in the slides? First, let me delete this move x2 comma 10. Now I'm going to remove this x2 and replace it with an immediate value number 5. Let's build it. There you have it. I have 15 again. If I change this to 50, it's going to give me 60. That's all we have about the add instruction. See y'all in the next video. Bye bye.